the key things, and then maybe collaborate and do great work. I'm sure we can do much more better if we can do a good collaborative effort. Yeah, thank you so much, Sharif. Thank you for your kind words. I don't know if I really deserve all of this, but thank you so much. And I've had several mentors. For those who don't know, at least 20 students from 20 different countries. That was the group that we had at Arizona State, and we were like a family, and it was excellent. We were traveling together to the TRB meetings and many other things. But well, long journey again, 20, 25 years of good quality research that we have embarked upon, and we were trained that way. Matt Witzak's group has always been trained to do good quality work and possibly do the best in the world. Obviously, he was the topmost pavement engineer of that time. Now, coming to my, I hope I can share this screen. Just thought I'll share it. Screen and here. Okay, I hope you can see this.
Yes, we see it.
Yeah, okay, great. So here is the title of the presentation, but then I thought I'll also give you a background about what I did. So I got my PhD from Arizona State in 2008, almost 16 years ago, and then moved to Sweden as a postdoc for about 2.5 years. And then I came back to the US, served as an assistant director of the National Center of Excellence on Smart Materials and Infrastructure. That was fully funded by US EPA at that time, and then it became self-sufficient. Later, I even taught a few courses at Arizona State. Then I moved back to India in 2012. Was with one of the oldest IITs in the country, with more than 15,000 students at one time. And then I got my promotion, tenured, and then moved to the current IIT, which is called IIT Tirupati. So this is one of the 23 IITs that we have. They're all sister IITs. They're all similar ranking and excellent facilities that we give to the students. But I also have been associated with the other two universities in the US, one Purdue as an external faculty. We have a large project with Purdue University, and then Arizona State as well. I've been working for them as an adjunct professor. So there is a project that we have, and I'll explain that, how we have embarked upon it, and then what we do with both of these universities in terms of transferring the technology and whatnot. And then I also serve as director of two boards. One is the Riverized Asphalt Foundation, based in the US and Portugal, and then International Road Federation. The recent conference that was held in Orlando also appointed me as a chair of the International Road Federation Committee on Sustainable and Resilient Pavements. So that is the latest assignment I have got. Chair of the IRF Committee on Sustainable and Resilient Pavements. Apart from this, I also serve as the Vice President of International Society for Maintenance and Rehabilitation of Transport Infrastructures, which is called the iSmartI. And you are welcome to join this iSmartI. This is free, so please encourage yourself to just Google this, and then please join our group. It's free. And then I also serve as a co-chair of TRB subcommittee on flexible pavement lifecycle. So we started this subcommittee just last year out of the several subcommittees that started. But we emphasize here on the life cycle. Today, the life cycle assessment is being done in silos. When I say this in silos, it's materials and extraction one, then operation one, exhaust one. So we would like to combine these and synthesize the various aspects of life cycle into one. So that is the overall aim of this subcommittee. And I also serve as a task group chair of RILEM. Some of you might be familiar with this EU RILEM. It's more of the materials and structures. So we have a new committee. We started a technical committee called Sustainability, and then Advanced Pavement Materials with alternative paving materials such as biobinders, rubber, plastics. So we serve as a chair of TG. It's a task group out of this bigger TC called the Field Evaluation of Alternative Paving Materials. So we will also invite you to join this RILEM group. So you have to be a RILEM member to be joining our group, but we have a large task group. So that's what I do. And then, of course, one company in India which does a lot of work on rubberized asphalt called Tina Rubber and Infrastructure. They also have a base in Oman. They are starting some work in Saudi and UAE. So I also serve as their independent director and help them with many other aspects. So basically, I'm a professor of civil and environmental engineering at IIT Tirupati, and then a fellow of International Road Federation Institute of Engineers. That's what I do. So thanks so much once again to the entire team here for inviting me for this guest lecture, mainly focused on the smart transportation infrastructure for futuristic cities. So I also have been nominated as the chairman of the Future Cities Conference that's coming up next year, Smart Cities, International Conference on Smart Cities that will be hosted in India in person. So please join us in India next year sometime in October, November. We are yet to decide on the dates, but that will be in Tirupati, hosted by India. So this is an outline of what I thought. 4 modules, basically starting with one module on what we do as a group, and then 4 major modules on asphalt rubber. That has been my core area of research for 20 years now. And then we started a pervious concrete research program way back in 2012 when I started my career at IIT in India. And then I'll share with you what all we have done. And in fact, we also have a cross collaboration with the University of Sharjah with Dr. Waleed. I believe he also gave a lecture a few weeks ago. So we have a cross collaboration venture between University of Sharjah and IIT Tirupati. Possibly that is the first time that University of Sharjah has collaborated with one of the Indian universities. So I'll also share more details about that later. And then one other thing I was just mentioning, between Purdue University, Arizona State, and IIT Tirupati, we have a technology transfer project fully funded by Government of India, self-charging technologies for electric vehicles. I'll share more details about this. And then finally, a little bit of circularity that is taking very good shape across the globe. And in fact, that is where I chair the TRB subcommittee on pavement life cycle. So we'll also explain to you what all we have been doing, and then the emerging topics in circularity of pavement systems. So this is a slide that shows to you a bit of what we do. We have a 50,000 square feet of lab space being built on campus IIT Tirupati. It's about 1 acre. So we are also building an accelerated pavement testing facility, first of its kind in the world, where 2 actual trucks will be running 10 hours a day. We can even run about one day, 24 hours a day, so that we can capture the accelerated pavement testing of real roads. So it's a 5.5 meter test section across 96 meter perimeter. And we also have a linear track, about 150 meter track there. So we can actually build anything starting from subgrade, ground improved materials, bases, sub-bases, and then the surface wearing course. So we are also trying to use various types of waste materials. So that is our core area of research as well, where we are using rubber, scrap tire. We are also using plastic waste. So I'll explain that later on. Then we also are working with the Ministry of Defense on composite wastes, such as the carbon fiber reinforced polymer, glass fiber reinforced polymer. So that is another niche area that we have created, apart from various other waste such as fly ash, pond ash, you name a waste material, we have it. So we are also embarking upon new products such as bio-based rubber binders. That is another area that I'll explain later. So we call ourselves materials for infrastructure, smart asset management and performance monitoring of smart infrastructure. We call ourselves Map Smart. We have close to about 15 PhD students working with me right now, and about 2 postdocs and many, many masters and bachelor students at the same time working with us. So as I told you, we do a lot of work on the fundamental research, binder, aggregates, mixture design, balanced mix design concept. And then we do a lot of advanced research, including using the UTM, Universal Testing Machine, and I'm sure many of the universities in Egypt also have this system. But what we do here, we do a lot of work on performance monitoring, performance criteria development, using the advanced technologies such as SuperPave, gyratory compactor, apart from the Marshall mix design that has been there for almost 100 years now. So we have a machine that can do everything at one go. So we have 2 machines of that kind. very soon we will have one more coming up. So this is the ongoing research activity. So we are coming up with mechanistic pavement design for India, which includes vehicle pavement interaction with real field testing done on national highways in India, coming up with new vehicle damage factors, real truck traffic, and taking into account the loading pattern, the axle distribution, and then whatnot. Okay, so all of these we are doing. And then we recently received another project from National Highways Authority of India, which is Government of India subsidiary, where we are going to build asphalt rubber test sections across India. So it's close to about $500,000 project that I'm championing across the country. So we will come up with some specifications very soon for AR. And then apart from this, we also work on this warmix asphalt additive that I'll explain later on. But what we do here, we are reducing the production temperatures and lay down, especially at the plant, the production temperatures, because whenever we talk about the fumes that are emitted at the plant, they're really at very high temperatures, very high emission of energy, and then the heat that is required. So we are trying to come up with new additives that can lower down the temperatures. Right. Apart from this, we do a lot of work on pervious concrete. I mentioned this a while ago. And then we have very good collaboration with state government, where I belong to, and then we do a lot of work on their pavement assets. So not only building, but also managing their assets. Along with these, we have a good industry collaboration. They have given us some good projects, especially on research-based industrial consultancy. And we do a lot of work on geogrids as crack relief layer in pavement systems. So we are building these geomembranes, geopolymers, and so forth in the real field sections, and then monitor it for their performance. Again, I mentioned this, so we are now moving into the next generation of electric vehicles, autonomous vehicles, and so we are now coming up with infrastructure to charge these without having the vehicles to get parked somewhere and then charge. So we are creating these dynamic charging facilities. To start with, we are having a static now. We already have come up with a schematic, and that is where we have a good collaboration with the US universities on this. And then I mentioned this, we have an accelerated testing facility coming up on campus. So it's a national facility for both pavements and vehicle dynamics. So this is what it looks like. So it's a circular track. It's now being constructed, so it will get inaugurated somewhere in May or June, very soon. In fact, we have finished the groundwork. So the track is getting built. Once the track is built, then we will have the real pavement systems built, and then the trucks are purchased. So we have 2 real trucks purchased from the manufacturers. We have customized them. They'll be running fully loaded about 18 to 24 tons load. So this is first of its kind in the world. In fact, I say India, but in the world, because most of the accelerated testing facilities, they do a single tire or a dual tire, but we are now building a real truck, both real trucks that will run across for hours together. So we will be able to simulate about 10 years of aging within maybe 1 to 2 years. So that is real accelerated testing there. So that being said, we have a lot of good collaborations with road industry, construction, infrastructure industry, automobile, because we're also trying to understand the noise, vibration, and harshness. Some of you, if you are from the mechanical engineering background, they call this NVH, and that is a very important aspect when you talk about the new vehicle manufacture. So we are also working on this to quantify the noise, vibration, harshness performance of these materials. And then again, rubber and tire industry, the tires that are being used in various trucks, that is another important aspect, right? So that is the application. And then the other aspect which I mentioned with the government, we do a lot of work on this mechanistic roadway design integration with the sustainable development goals. So when you talk about this vehicle pavement interaction, very few studies in the world have actually taken into consideration the real truck traffic or real traffic, and then monitored the pavement for their distresses and evaluated. So what we are doing right now is we are very strong in this in material characterization using the state-of-the-art equipment. But one thing that we are not able to mingle or co-mingle and then correlate is the real truck traffic coming into the system, and then the sustainability aspect coming with the serious damage that are occurring on the environment or the economy, human health. So we are now strong in this, but we also have to integrate that with the life cycle aspect. So that is another module that I'll explain to you later on. But then life cycle, when we talk about life cycle, these are the 6 or 7 or 11. Some people talk about 11 or 12 hours: recycle, reduce, reuse, rethink, remanufacture, many, many other things. So we have a lot of work that we have done on the resource consumption, reduction of the natural resources, such as the aggregates, come up with new type of aggregates, including tire derived aggregates or plastic modified rubber. Okay, and then we do a lot of work on this end of life automobile, and I mentioned this about composite wastes. So this is in a nutshell, this is our vision from the group, and I'm sure most of you have certain similar type of certain visions. But if you talk about the current status of the world today, we do this recover and recycle. That's called the linear economy, where we talk about government funding us, come up with material characterization, development of standards. But what we should be doing, and we are at the cusp, most of the countries are at the cusp of semi-circular, where we talk about remanufacture and reuse. So we talk about recyclability, product development, and then come up with the EPDs. Okay, and then we talk about LCA, life cycle assessment. But what we haven't been doing is a fully circular economy where we rethink and reduce the emissions, energies that gets integrated with the materials aspect and then the product development. So that's where this holistic approach of integration of mechanistic models with LCA comes into picture. That also brings us to the point where LCCA also gets nurtured. When we say LCCA, that's a life cycle cost assessment. And so that's the circularity that we envision through our group, both at the national and international. So the first module, technical module, I'll not take much time. I'll just go through these maybe 10 minutes each. That gives us leverage to solicit questions from whatever that you people can ask me, and then if I know I'll answer that, and then we'll collaborate in the future. So the first module that I thought I'll talk about is the asphalt rubber technology, and has been very close to my heart because I've been working on this for 20 years now, and I'm also the asphalt rubber ambassador for India through the rubberized asphalt rubber conference group. It has been organizing conferences across the world. It started in 2000 in Portugal, and the next conference also will be in Portugal. That's 2025 in Lisbon. That's the 25th year anniversary. So please feel free to contact me, and we will put you on to the right people. Please also encourage yourself to submit some good papers on rubberized asphalt or asphalt rubber, use of rubber crumbs in asphalt pavements. Okay, so that's moving from linear circular economy. How is it transformed? I'll explain this to you very quickly. So if you talk about asphalt rubber by itself, the definition from ASTM, the American Society for Testing and Materials International, very clearly says that when you blend at least 15% of rubber with asphalt cement, only then that binder is called asphalt rubber. Anything less than 15% is not called asphalt rubber. It could be called rubberized asphalt, but cannot be called asphalt rubber as per the definition of ASTM. Reason being, the swelling of rubber particles takes place very much only beyond 15%. So people have tried 20%, they've tried 30%. So it also gets saturated about 20-25%. That's a magic number. So if you go to Arizona in the US or to California, they've also used 20% rubber, very much. Okay, Florida and Texas, all of these states have used. And there is another terminology called the terminal blend, which is a rubberized asphalt, where they blend rubber and replace aggregates with rubber tire crumbs. Okay, that is called a rubberized asphalt. So please don't get confused. One is the asphalt rubber, where you use crumbs with asphalt cement, blend them. That is the wet process, which is called asphalt rubber. The other is the rubberized asphalt, or the terminal blend, where they blend rubber crumbs with asphalt and aggregates. So replacement of some aggregates with rubber. Okay, so these are the two important aspects. One is the wet process, the other is the dry process. But what I'm talking about is the wet process here. Okay, so 100% particles from rubber particles, finer than 4.75. So some of you are familiar. I'm sure 4.75 is the benchmark between coarse aggregate and the fine aggregate. So anything beyond 4.75 is a coarse aggregate. Less than that is fine, right? So we are looking at specific gravity of about 1.15 of the crumbs, so tire crumbs. That's close to the binder specific gravity. So 1.01, 1.02 is what we see with asphalt cement. And that's how these both gel very well with each other, right? So 80% bitumen or asphalt cement with 20% ground tire rubber is what we call the asphalt rubber. They are blended to form a binder and they are pumped to prepare mixtures. Okay, so no sophistication required. It's the same plant. I'm sure you are familiar. Some of you might be definitely familiar with this. So what are the applications of asphalt rubber technology? One, as a friction course, and as Dr. Sharif rightly mentioned, it was the key thing. That's how the quiet pavement program started way back in 2003 in the US, where they surfaced the friction course on the Portland cement concrete base course. So what happens here, this is one of the best, or I would say successful blends, a composite structure where you have an asphalt rubber friction course about half to 1 inch, about one, when we say 1 inch, it's only about 25 millimeter, right? It's really, really thin friction course resting on the Portland cement concrete, very strong structural layer. So that gives us a very good strong base and a friction course that helps drain down the water, and that gives you a very good skid resistance, very good noise reducing capabilities, and also engineering use of old tires, because you're using about 15,000 tires per lane kilometer. That's a very good circular economy concept. So waste to wealth, that's what we call, right? Apart from these, also used in asphalt by itself. So there is a new or an existing HMA, hot mix asphalt. On top of that, you provide a gap graded asphalt rubber, a strong structural layer, and then a friction course on top of that. So you see here open, gap, and dense graded structure. So some of you might be familiar with this. And this asphalt rubber has been used in very hot climates and also cold countries, both ways. So all the way starting from minus 40 degrees Celsius until about 80 degrees Celsius pavement temperatures. Very successful product. So the umpteen number of benefits, as you see. And we also have an asphalt rubber standard practice guide. I'm also a co-author. In fact, if you require this, please send me an email and I will send you this standard practice guide. It's free to use. So the benefits, as mentioned here, definitely very less maintenance, high durability over the design life. And again, not mentioning very much, but good rot resistance, high skid resistance, very smooth ride because it has open texture. And I mentioned this hot and cold. Very important thing, cost effective over the long run because you don't have to maintain much. But importantly, for all the engineers that are there here and practitioners, it's a very high engineering use for old tires because we use about 15,000 tires per lane kilometer. And the first campus in India that used asphalt rubber, about 5 kilometers that we built in my own campus, IIT Tirupati, we used about 75,000 tires. So that is a very good application. We have not seen even one crack in the last 5 years. So we designed ourselves and we placed it, did a good quality control on these. That gave us good benefit there. So, and we also talk about LCA of this product, life cycle assessment. I'll explain to you what is LCA later on. But when we say LCA, that means we are looking at how well this product compares itself with relative to the other products that are there. So the kg CO2 emissions per lane kilometer per year. That is what we look at, the emissions and the energy that is required to build these. And you see here, the energy is exactly half that you compare with the conventional HMA. It's a very, it's a published paper, very high impact journal, RCR. In fact, I'm also an editor of this journal. So please feel free to read this paper, and if you have more questions, I'll be happy to answer this. But in a nutshell, when you talk about LCA, that also goes back to the service life. I mentioned this. If you are able to get a good product, durable product over time, you're also emitting less energy, less emissions, right? So that's the total kg annual CO2 equivalent per lane kilometer versus design life. So higher the design life, lower is the emissions from that particular product. So asphalt rubber stands out as the best out of the three that we see: ultra thin white topping, and then the HMA. We are comparing three different products. Again, we have done a lot of work on this. This is way back in 2010 when I was with Arizona State. We did a small work on this, but we have now expanded this to suit. So here is another slide that talks about two state-of-the-art reviews on asphalt rubber. If you want to read more about this, two of my students in the past, both of them are now professors in two different universities. One, Veena, she actually worked on a new gap graded mixture design, fully suiting Indian conditions. So there are umpteen number of gap graded mix designs across the world, but we said, no, we want to do it for Indian traffic conditions, Indian demographic conditions, Indian geographic and soil characteristics. So I encourage you people also to do this. Please come up with your own designs, because some of the times what happens is if you bring in standards from elsewhere, they may not suit your conditions, especially if you have a very high traffic in Egypt, or maybe the temperature conditions are different across this board. The other aspect is we also came up with new technology for asphalt rubber, where people have always talked about the storage stability of these products. Can we use it beyond 2 hours of manufacture of asphalt rubber? Today, no, because it gets settled down, so that storage issues are there. So we came up with a new product called the recycled or modified asphalt rubber, with various types of industrial wastes and nanotechnology. So that also I'll explain to you later on. So if you want to read more about this, so what we did, one small project with the Government of India, Department of Science and Technology, we came up with mixed design practices for asphalt rubber, and it actually was developed in lines with globally accepted super pavement. So the first project in the world, in fact, on using super pave for asphalt rubber gap was us. So we did this, we established our own protocol. So here is the design parameter selection for the entire mixture. So we had 20% rubber passing 300 micron C. Okay, and then we use super pave mix design, unlike the Marshall mix design that is conventionally used. So, and the air whites that you see here, so you can come up with your own design. Okay, when I say this is the design, this is not the end. You can also come up with your own novel design. Okay, you can come up with these designs based on the balanced mix design as well, coming up with performance criteria, including the rutting and cracking with respect to the aggregate gradation, binder concepts, volumetrics, and many other things. Okay, so this is a published document in the Constructional Building Materials, very highly impacted journal there. Okay, so we also did a demonstration section, an actual pavement section, where we just paved the surface wearing course 40 millimeter. It's about 1 to 1.1 inch, 1.2 inches there. Okay, on top of the existing sections. There were many layers below: dense graded, wet mix mechanism, granular subbase and subgrade existing there. We didn't touch any of those. We just put a small section, thin section, and this was constructed way back in 2017. It lasted for 4 years with no cracks. And then later on, the state highway, this was a state highway that we paved. It later on became a national highway. It was widened to include about 4 to 6 lanes. So they had to repeat off, but it was functioning very well. You see here, this is the close-up view of that section. Very soft, very smooth structure, very high binder content to resist rutting and cracking, with the rubber granules very much inbuilt. Okay, so here is what you see: control sections getting cracked, pothole, but our sections very much intact, no cracking, no minute cracks as well. So 4 publications that came out of this in 4 different journals that you see, including in the TRR, Transportation Research Record, or the RMPD, ASTM, and Construction Materials. Okay, and then 2020, they actually repaved the entire section. Then the other aspect that I was mentioning to you, so we came up with this modified asphalt rubber with several nanotechnologies and then industrial waste products. So what we did is to start with, we came up with a montmorillonite. Some of you who are geotechnical engineers, you might be very familiar with this. It's a nano clay, very much abundantly available on Earth's crust. You take that, okay, obtain it from the soil subgrade, and then start using it to create modified asphalt rubber. How do we do this? There is a process. It's a published document. I'll not go to, in detail, but what we do, we pulverize the asphalt materials that are activated. So we have these rubber crumbs that are blended with asphalt cement at varying dosages. So here you see there's a base binder and then crumb rubber. You see, I mentioned this based on the ASTM, it is about 20% is what they are stating, right, for an asphalt rubber. We even went to about 46%. In fact, recently, one of the papers that we published has about 60% rubber. So you can go until about 60% rubber now instead of just 20%. That means you are now getting into the circular economy concept. Okay, so we have this as the ingredient that gets charged. So we activate those rubber crumbs with base binder and some other materials called the lime. Lime is a known product to most of you. Monuments that are there in Egypt. In fact, your pyramids that are there have lime in them. That's why they stay for a long time, about 5,000, 6,000 years they've been there, right? But people have neglected hydrated lime because they're expensive. Okay, so we actually came up with this product, lime with organo-montmorillonite. So we charged these montmorillonite sections and then clubbed with hydrated lime and then blended that with rubber and base binder, AC10 with rubber and lime OMT that we prepared in our own lab, okay, and run it through drying. That gives us the pulverized, powdered, modified asphalt rubber that could be simply replacing a lot of aggregates that are finer than 4.75. So that means you're also conserving natural resources, natural aggregates, using rubber crumbs. That brings in that win-win situation, waste to wealth. So it's a resources that are conserved and also recyclable. So that's how this modified asphalt rubber has been prepared by us. You can see here modified asphalt rubber powder pulverized from the chunks. And now we've also gone into the other stage where we are replacing the montmorillonite with fly ash, pond ash, ground granulated blast furnace slag, and many other industrial wastes, including composite waste. So what we do here, it's very simple now. If you go to the plant, you don't have to change any of these structures there, nothing required. It's simply a semi-dry process where you have the MAR, that's our product. Okay, you simply dump it into the pug mill in varying proportions, and you still run the other processes as there. Okay, which means you have your asphalt cement coming into the pug mill, the aggregates coming there, you have your the new product that is being blended with the asphalt cement and aggregates, reduction of the fine aggregates with MAR. So it's still a great product because we have seen that this functions much better than the conventional asphalt rubber in terms of fatigue resistance, rot resistance, and moisture. It's a published document. You please visit this journal and please download. We call this MARG-PAVE, modified asphalt rubber green pavement. So we have used nano clay and then industrial products there. It was a full PhD from one of my students in the past. Okay, so and then we did a lot of work on the LCA, life cycle assessment. So here you see we use something called the attributional allocation at point of substitution. In simple words, how it works, you need a simple, what do you call the, you have three different things. One is asphalt cement, the other is aggregates, the other is rubber. So we combine all of these and we come up with what we call the specified temperature and time concept, what we did with the binder and aggregates. We activate that, okay, and then we cool it at room temperature, which I mentioned to you, and then the pulverized product. So we take this pulverized product to the plant. So we also talk about the mixture extraction separately. We talk about transportation separately, and then to the plant. So we do an attribution allocation, which means we don't combine any of these. We talk in silos, and then finally the product is compared against what we call the life cycle inventory. So we have the primary data coming from the material suppliers, such as the asphalt, cement, aggregates, and so forth. Then we talk about this, because if you don't have this product already built, you'll have to be dependent on the secondary data, especially some of the databases that are very strong, such as the EcoInvent that is existing. Okay, that's the literature. And then we have this hydrated line that is already existing. I'm sure it is there in Egypt as well. Then we calculate the material proportioning. We have done that here. This adds up to 100%, right? And then what we do, next stage is calculate the energy. So if you want to talk about the LCA, you need a functional unit. What is this functional unit? You have to target an N amount of material to compare this with the conventional product. So what we did here, we compared 1 ton of modified asphalt rubber versus the 1 ton of asphalt rubber product, and then 1 ton of the conventional. So that is the functional unit per lane kilometer. So you need to specify this for an LCA to run. So functional unit is very important apart from the life cycle inventory. So you need to create a life cycle inventory using your primary data source. And if you don't have some of the databases, please rely on a very reliable database such as the EcoInvent or some other. Okay, run it through a software, or you can create your own LCA package, which we did, in fact. Okay, and we calculate the energy coming out of these. So for blending and activation of this modified asphalt rubber, the energy consumption was about 30%, okay, 30 kilowatt hour. Pulverization was the largest, obviously, because you'll have to run through a process which will bring it to a powdered form, right? And then transportation, which I assume will not be much if you're doing it in your own plant. So basically what happens here is when you run it through a software, it'll actually ask for all of these. Now, let's say you create your own LCA package, then you'll basically see that you don't need to even include the transportation sector, right? Okay, so if you can run it through various other types of assessment methods. In fact, we use midpoint impact here, but there are other types such as the endpoint that also can be used. Only make sure that you know the endpoint as well. In our case, we did not know that, obviously, because we were looking at the cradle to gate, or what we call the production to plant level. If you want to compare this with the operation and exhaust phase, then you'll have to be using the endpoint, which we couldn't do because of our own limitations of still producing the product. So if you look at this here, modified asphalt rubber versus the asphalt rubber, obviously the GWP was higher, as you see here, except for the fact that crumb rubber by itself takes up a lot of energy in terms of shredding. So let's assume the government is giving you a subsidized rate. Then you basically see that MAR functions much better than the AR, as mentioned in this case. Okay, so you're looking at the impact categories. There are 18 different types of categories. One is water consumption, resource scarcity, land use, carcinogenic toxicity, and then leachate potential, global warming. Basically, MAR functions much better than asphalt rubber in terms of resource scarcity, because you're using industrial waste, so that's a win-win situation. And also, it functions very well in terms of radiation that you see here, and also acidification. So you're looking at 76 scrap tires being recycled in MAR, modified asphalt rubber, versus 37. So it's double now that we can use recyclability there. And now again, declared unit, I mentioned this already, the functional unit is 1 ton at 5% binder. So I'm sure you have a binder content in your country as well. It could be 5 or 4.5, 5.5, something like that. So what we do here, we calculate the embodied energy between the virgin binder and crumb rubber modified asphalt rubber. And you see here about 1/3 embodied energy gets reduced when you use asphalt rubber there. And also GHG comes down by 250 times. So that is something really, really big, right? So what we have been able to clearly state with our studies, we have found this, we have concluded, inferred that recycling of rubber definitely yields in a very sustainable development of the infrastructure. Okay, the next module that I thought I'll talk to you is the pervious concrete. Again, this particular product has been there for almost 40 years. Okay, various countries have used this, New Zealand, Australia, Canada, US. But what we thought, we'll develop our own product for India. So when I came back to India in 2012, we said we will embark upon a project called Pervious Concrete for Future Cities. So this is a product that could be used to ameliorate the problems that are coming from the infrastructure. For example, when you have rapidly developing cities, I'm sure Cairo is also rapidly developing with urbanized setup. what happens there is with pavements, it becomes impermeable. So there's no way that water gets percolated through, to the groundwater. That means you also have a little bit of groundwater recharge getting reduced. Over time, quality of life also gets reduced. So there are two aspects that comes with this. One is the change in the urban hydrological aspect, where you don't have good groundwater recharge. The other is the temperature increase. So if there is an impermeable structure, there is also this heat that develops within the city. And I'm sure you'll experience this with respect to the rural setup. So when you go out of the city, you'll see that there is about 2 to 5 or maybe even 10 degrees Celsius decrease of temperature with respect to the city, right? And that's called the urban heat island. So if you want to target both of these at the same time, you'll have to create something called the sustainable urban habitat, or what we call a pre-urbanized setup even after construction of the roads. So better recharge comes with pervious ground, right? Reduce recharge with built up area. So what we should be doing is we target a pre-urbanized setup with good products, green products such as the pervious concrete. Pervious, when I say, it's permeable in nature, and that gives you a pre-urbanized setup, meaning you have very good groundwater recharge and also reduces the urban heat island effects there. So what is pervious concrete? In a nutshell, it is simply a regular concrete, except that you have very less amount of aggregates or no fines at all, absolutely no fines. Very high void ratio, very high porosity, about 15 to 20%, maybe 40% sometimes. Same cement that you use, water and aggregates. You might start using additive materials such as supplementary cementitious materials, example fly ash or silica fume, or maybe GGBFS, rubber granules to increase the strength of these materials, because it has very high void ratio. You can also expect that these materials are low strength because they also have interconnected pore structure. So what we have seen is this can be applied in low volume roads, parking lots, pathways, and walkways. So if you look at the interconnected pore structure using X-ray microtomography, this is how it looks. The top 25 to 30 millimeter in a 150 millimeter sample gets clogged because it has very high interconnected pore structure. So one of the major demerits of this kind of material is that it has very high porosity, which means it can get clogged. So that question always remains. So how do we mitigate that? So that is another question that we have. So if you have a composite structure, so you prepare this in 3 or 4 lifts, you can start removing the top layer and then replace it with another layer over time. So we have seen that these materials get clogged only once in 3 to 5 years, not less than that. So if you can prepare a top section with pervious concrete, and then also below layers, so also pervious concrete, you can start using double or multiple layers of pervious concrete. Only top layer will be removed every 3 or 4 years as maintenance strategy, right? So that is another way of dealing with clogging there. So here is one state-of-the-art review paper on pervious concrete. Please feel free to visit this. Another paper also on pervious concrete that talked about clogging effects. So the previous paper had my student here. He's now a professor in one of the other IITs. Avishesht was my previous student, one PhD. So now he is in Netherlands working as a postdoc in TU Delft. Okay, so both of them worked on this for the last 10 years. Okay, so we have done a lot of work on this compressive strength. In fact, we did a lot of work on flexural stiffness. We have done work on thermophysical properties such as specific heat capacity, thermal conductivity, X-ray microtomography, permeability, many, many other things. In fact, we've also done the abrasion resistance to understand the raveling aspect. Okay, so here is a glimpse of what all we did after we have come up with the product. So we built 3 different sections. One low volume roads, parking lot, a real road with 30 slabs, and then another parking lot on campus IIT Tirupati. All of these 3 sections still exist even after about 6 to 8 years now. Okay, so what we did, you see here, the mixed design composed of again, cement, aggregates, and then super plasticizer to make sure that there is good workability. So the compressive strength varied between 10 and about 20 MPa. So M10 to M20 concrete is what we targeted, low volume roads. But the infiltration, or what we call the permeability, was very high. So if you talk about these numbers, they can be translated to about 70,000 millimeter per hour. That's the permeability that you get with these kinds of products, but they recharge very well. They recharge the groundwater. They are also very strong for low volume roads. Okay, you can run even a JCB on these. In the next stage, people started to question us. Oh, yes, it gets clogged, but it cannot be used as a high volume or medium volume road. So what do we do? So we came up with new technology, what we call the Parampave. It's a pervious all road class, all weather, multi-layered paver blocks. So they are paver blocks. They are 1 foot by 1 foot. So 300 millimeter by 300 millimeter. Okay, so what we did here, we created 2 holes in a concrete block. It could be M70, M50, whatever that you want. Okay, so if you want to have M50, you please manufacture that base with concrete and then impregnate this small portion with pervious concrete. So what we do here, you see here, this is a 90 millimeter height of the concrete block that you create using a mold, a square mold that you see here. Impregnate this groove with pervious concrete. And these holes also are filled with pervious concrete. That is something that you want to be aware of. Now, if you ask me, can we have more than 2 holes? Well, 2 holes are sufficient to make sure that there is good permeability. But of late, my other students have also started to work on, can we come up with different designs of holes, maybe 3 holes instead of 2 or 4, or different types of designs. We have also worked on the numerical modeling and come up with different designs, which we can share with you in the next 6 or 7 months. But overall, you need to create a base with a concrete, regular conventional concrete, impregnate that with pervious concrete. So that's a published document. Let me show you the video, how it works. So here you see, you create this slab with a concrete mold, okay, M50, M40, and then you have a hole that also is with pervious concrete. And here is the wedge that you see with pervious concrete that we built. Okay, so we get very good porosity, no compromise on that, anywhere between 16 and 25%. Very similar to conventional pervious concrete. The other advantage that we got here was the flexural strength increased by about 3-fold. Why is that? Because this pervious concrete doesn't have a concrete base. It's a regular pervious concrete. It's a slab 500 millimeter by 500 millimeter, or maybe 2.5 meter by 3.5 meter slab that you regular construct. You construct a concrete section regularly. No, you don't want to do that. You want to create a pervious concrete block. That's called the Parampave. So we get a very good flexural strength, about 4 to 6 megapascal beyond what the ACI, the American Concrete Institute, prescribes. So what we did recently, we constructed 850 meter of smart city roads with our blocks, as you see here. And we also calculated the cost savings coming up with our paver block, about 10% cost savings per block. You save about 5 units. I'm putting it in Indian rupees, but you can calculate that in dollars or in your currency. It's not very far. It's about 10% cost savings. And also it's lighter. It's about 2 kilograms lighter than the conventional concrete block. Okay, with respect to our. So the costs have been calculated based on linear lane kilometer and for a 3.5 meter wide section. So you look at about 200,000 Indian rupees saving per lane kilometer. So that's approximately, if I calculate that, about $3,000 a lane kilometer savings. That's substantial if you talk about this. Okay, so really big savings coming up with these products. It's again published document in International Journal of Pavement Engineering. And then I'll share with you one small video how we did this construction. I'll explain this, maybe the audio. So this is my office. Again, I'll just move this. I'll just explain to you. So I had one of my PhD students, one of my master students working on this. So we had 4 sections built, one in 2017, one in 2018, one in 2019, and then recently 2023, just last year, early this year as well. Okay, so what we did, again, structural layer, bottom view, block width impregnated with pervious concrete. Okay, so this is the structural layer. This is the functional layer with pervious concrete. So what we did a lot of survey on this. We prepared the subgrade and a base course with a granular base course there. It was continuously with traffic. Okay, and then we compacted the base layer with a roller. We had about 18,000 slabs that we created in our yard. We brought it to the site. We started to lay simple laying. You see one next to each other, as simple as that. They all get locked with each other. We had our contractor being very happy because we could finish the entire thing in one day. Okay, and then you see water being splashed. No water remains on the surface. So you can see here all kinds of traffic run, 300-meter first section, and then another section 550-meter later on, so 850-meter. There you see, so here is the texture of the, so we had 18,000 slabs. I can share this video with you later. So here you see, so 18,000 blocks, 0.8 to 1.5 centimeter per second, very high porosity, very high flexural strength, very high compressive strength, about M35, M40. We also instrumented these sections with thermocouples. We are now monitoring these sections for their thermophysical properties. So this is the laboratory permeability apparatus that we have created. There's no ASTM standard, so we had to do this. So we also had municipal corporation helping us. They supported the entire project here. We spent quite a bit amount over there. Okay, so that's what we did. Now, if you ask me, the cost savings about 50 units per block, including the construction. Okay, and we only spent very little amount on the construction aspect because the blocks were very cheap. Okay, here is the, in a nutshell, what it does. And we did a lot of work on the life cycle. Again, material extraction to end of life. Okay, if you talk about life cycle by itself, raw material extraction phase, the material processing. Third is the product development phase. That's much more important than anything else. And then the product use phase, wherein you can monitor the performance. We can also see if we need to do some rehabilitation, do some maintenance in between, routine maintenance, preventive maintenance, overlay, whatnot. Okay, and then once the design life is complete, then that is called the end of life. We might even be able to reuse that. So linear economy, end of life, we cannot use. Semicircular economy, we don't need to actually do any maintenance, but possibly use the structure again. If you talk about fully circular, every stage can be used. That is where we should be leading to, right? So waste to wealth. So we did a comparative life cycle assessment study. We calculated the embodied energy, kg CO2 equivalent, and also the cost, capital cost. We used something called the cradle to gate, where we manufacture and leave it at the plant level or maybe at the field level. And then, very importantly, this kind of a study can be expanded to even structures. Don't get me wrong here, it's not only for pavements, but for any structure, including buildings, bridges, etc. So you can use our framework. It's a published document again. We quantified the embodied energy for pavements. It's a published document in Resources Conservation Recycling Journal. Please visit this. If you don't get it, let me know. I'll share with you. The framework was developed by us in simple MS Excel. We didn't have to depend on a licensed software. And we did an environmental impact study between the in situ preparation versus the RMC, ready mixed concrete. We found that with the models that we developed using MS Excel for embodied energy and kgCO2, okay, you see here, we can now look at the materials aspect, production, transport, and also the end of life. So you see, it's a very comprehensive toolkit that we developed here and compared between different types of materials. So these are the calculations or the formulas that we developed, and we now calculate between the regular concrete versus the pervious concrete, in situ versus the RMC. You see here very clearly what we see, about 6,000 units reduction in kgCO2 with respect to our pervious concrete embodied energy. Same thing with GHG, about 6 units reduction, which means the overall cement production that contributes to the kgCO2 gets reduced. That's substantial, okay? So these are the numbers for 1 lane kilometer and for the products that we use. Again, you can come up with your own toolkit, and then you see the numbers that come up are very substantial, okay? So cost also we calculated about 1,000 to 5,000 units reduction. That's important, okay? That's what you see with capital cost, 5% decrease. It's a published document again. Please read through this. We've also done with respect to the regular cement concrete about this is 10 power 3. So make sure it's 90 times 10 power 3. That's the reduction that you get, substantial. Okay. So high strength that we can get with our new product, less material requirement, less energy, less emission, lighter, and then also cheaper. Than. The last 2 modules will run within 5 minutes. I should be able to finish this and solicit questions from all of you. So the next thing that we are working on is the self-charging technologies, wireless power transfer systems in pavement. So the idea here is we have 2 coils. One coil that exists within your electric vehicle. It could be a car or a 2-wheeler or a 3-wheeler. So you have secondary coil in your vehicle, a primary coil that we embed within our pavement block. Okay. So you can also do this. It's not difficult, except that you have to contact us, what we do with our materials. Okay, so we magnetize this particular product and we put the primary coil embedded within it. Okay, and we charge electric vehicles through our magnetized material. And in case you don't have an electric supply, you can also go with a windmill or a solar grid or any other type of grid that can supply to you the power required to charge your primary coil. Okay, that's very important. And what we have also done here is to check the lateral and the vertical elevation of, so that's what we call wireless power transmission. So it's a wireless now, very clear. So if you want to charge your electric vehicle, so what we did, we had a conventional concrete pad embedded with primary coil, and this is what you see here. Okay, wireless power transmission system. And then we've also calculated the power efficiency of these coils. We see that if you can magnetize these concrete with, for example, a steel slag. Okay, this is the product that we are developing right now, steel slag concrete, about 50% replacement of cement with steel slag. What we can expect is very high magnetized moment. Okay, and that's how so this is our lab setup. We have now calculated the efficiency to be about 85 to 90% higher than a regular conventional concrete. Okay, so what we did, I'll show you now a video. So if you want to create a 500 millimeter slab here, okay, and then embed these slabs with primary coil. This is the secondary coil within your electric vehicle. Now I'm going to move it up. You see here, it can go until about 200 millimeter distance from the coil. So if you have an electric vehicle that has a clearance of 200 to 1 or 150 to 200 millimeter, your primary coil will start charging your secondary coil embedded within your electric vehicle. So it's a self-charging infrastructure. You don't need a separate infrastructure. You can have your roads dynamically charged. So that is what we are doing. And we will be having our test section built within the next 1 week. In fact, we have got clearances. So we will be doing that very quickly. And then circularity is the last module, couple minutes. So if you talk about life cycle analysis, I mentioned this to you. So we'll have to be integrating this with the pavement design. Today we don't do that. So we do the material extraction. We have a product phase, then the use phase, maintenance, and end of life. We don't integrate the pavement design phase. So what we want to do is integrate pavement design with the entire pavement life cycle. That gives you a holistic picture of what we do in terms of life cycle assessment. Now, if you talk about life cycle cost assessment, that brings in the other aspects such as the construction, maintenance, vehicle operating costs, okay, delay and accident. So there are two aspects here. One is the agency cost that takes care of the construction. The other is the road user cost that takes care of the operation phase. Now, if you combine both of these, what we get something called the present value over the design life. So what happens in 10 years, we calculate today. And that is called the present worth factor, right? That's the current value of the entire system that remains for 10 to 12 or maybe 25 years. And we calculate the life cycle cost at present for the future. And that brings in something called the new concept, social discount rate. So this particular social discount rate has a definition. It's a very tricky definition, but we can simplify that by saying that if you want to bring down your future costs to present value, that we call discount rate. But if you want to calculate the social discount rate, you will have to come up with socio-economic factors, social factors, and the economical factors, which means your perceptions have to change. That if I invest today on a larger product, on a larger product, the pavement project at a network level, I will be able to reap the benefits of cost savings over its design life. So your perception should be that I should have a long-term vision of cost savings today. Don't look at the myopic vision. When I say don't look at what happens today, I will only fix it now, but leave it at a later stage to be rehabilitated. That cannot work in a social discount rate. So I should be discounting it. So that's what it is discounting. So I should be looking at the cost perception for today's savings. So we did a small work with conventional discount rate for 3 different countries. So we have, by the way, we have data for 35 countries today, all across Europe, India, Asia, China, and many other places. If you have data, we'll be happy to work with you closely. So if you talk about conventional discount rate, you see the numbers are very high, with respect to the developed countries. So we are emerging economies, so our numbers will be high because we look at today's savings and not worry about the later, right? So that is the perception that we have. Now, if you talk about the social discount rate, I will be looking at what? Prioritization of savings, investments for future consumption. I will also take the risk, but avert it by making sure that I have the psychological biases that are not in picture at all, which means my visions are long term. I will be making sure that my savings today that I invest more are savings for future. And that is what is the overall social discount rate. And you see here the numbers are coming down. These are realistic numbers, by the way. These are based on actual values that we got for various countries. And again, we have data for the others. And in a nutshell, why do we have to transition from conventional discount rate to social discount rate? For pavements to be in particular, because we are looking at societal preference, economic factors, and demography. So I look at how many people are going to live for that number of period. That brings in the demography. In terms of pavements, the same analogy works. How many years does my pavement last before it dies down or it fails? Second thing, how much do I invest today, not for the immediate gains, but for the future benefits? So I prioritize. So developed economies have always been doing this. So I prioritize the future benefits as against the immediate gains. So that is the societal preference. So determination of social response for, the preference, that brings in the risk perceptions also into for it. And we look at the socio-economic conditions between the emerging economies and the developed countries. So if you look at the return for investment, so I want to get more what I invest today, then you get higher discount rate. But US or the developed economies, they get a lower social discount rate because they've already prioritized. Okay, the depreciation will be very high because I look at societal preference. Now, social rate of time preference brings in that time frame wherein I encounter the entire design life. In that case, there is increased relative value of asset at present, brings down the social discount rate, which is a good thing, and it reduces the risk in resource distribution. How do I understand this in very simple terms? I have investment today, future investment. So what I should be doing, I calculate the social discount rate because I want to save money for future. And that also brings in that I have very high cost that I invest today, but I save for the future, meaning prioritize the future benefits. So I want to make sure my investment that is done today is not wasted. So I prioritize it. Okay. So we have societal preference, road infrastructure, economy, three important facets that brings in intertemporal decision making. Okay, so this is what we have done, and we have a lot of good data. But for you, the last slide, if you want to work on these various aspects, so we have the SDGs, Sustainable Development Goals of the United Nations, social equity, economic development, recyclability, construction. So this black color talks about linear economy, blue talks about semicircular, and maroon talks about the fully circular economy where we have to be moving towards. So with this, I end my presentation, and sorry for taking about 5-10 minutes extra, but I thought I'll explain to you the social discount rate and where we have to be heading towards. So thanks so much to several people who have been with me over the last 20-25 years. So please feel free to visit our group. And my email is here, and the phone, there's also WhatsApp. So please feel free to email me and also call me if you have any questions. And this is how the city that I live in looks like during deep winter, but we have very good greenery around. Thanks so much, and I'll now stop sharing and solicit questions. Thanks so much, Sherry.
Krishna, thank you so much for this very interesting journey through your recent research. Actually, what you're doing is really very trendy and very beneficial for your country and the whole world as well. I personally learned from some of the your research work here, and we maybe benefit in Egypt from what you have presented, and I guess Dr. Hassan will share with me, because lately we are experiencing a very high price of bitumen, which makes it really harsh on the country to establish like new roads or to maintain the existing roads, and we are looking for different alternatives. Not only from the environmental point of view, but also from the economic point of view as well, because this is really very important, especially with our economic structure right now in Egypt. We face like a lot of economic crisis, and we are looking for different alternatives. So what you have presented about the pervious pavement, I have a question regarding this, because what you showed when you went to the concrete blocks, and I see Dr. Hassan looking at this point as well, you still have a very good compressive strength for your blocks. So this could be applied for like major roads, not only like low volume roads or parking lots, as we usually, when we think about pervious concrete, we only think about, you know, parking lots or like low volume roads. So like, do you agree with me on this? Can we use these concrete blocks in like heavier roads as well?
Absolutely, that's the intention. In fact, we've had questions in the past when we were developing this pervious concrete. What about high volume roads? Can we come up with a composite structure? So we said we will have a structural base built with M40, M50 concrete. That's what we did. And then we had a groove within them, and then we have now impregnated pervious concrete within them. So it's a functional layer over a structural layer that behaves as a composite structure. So we have now used it in high volume roads. In fact, that is a technology that is being transferred to University of Sharjah as well. So we have a project between University of Sharjah and India, where we are transferring this paver block to University of Sharjah, possibly to UAE, where we will be building test sections next year.
Oh, excellent.
Absolutely.
Excellent.
Absolutely. So we can also come up with some technology transfer between Egypt and India very soon. With this technology, sure. especially if you have very low groundwater recharge with impervious surfaces, this is the product that we should be using.
Mm-hmm. Yeah, this is impressive. Yeah, I think we will think about that, and we might
sure.
discuss this more with you.
Sure, absolutely. Welcome.
All right. Dr. Hassan, do you
Thank you. Yes, thank you for the nice presentation. We see new technologies in your presentation, and I have some questions. Maybe you know that we have a problem we are facing in infrastructure in Egypt, what is called the overload, and I am asking if using, for example, rubberized asphalt or using crumb rubber in modifying the binder or the asphalt mixture can enhance this problem. Also, what about non-load associated cracks such as thermal cracks, and can crumb rubber be used in this situation? And this is regarding using crumb rubber. I think it is a type of polymer in modifying the binder. Another question is, as Dr. Sharif said, we have problem with binder now in Egypt. So we are facing, we are searching about another alternatives for paving. We're using what is called block paving. We use interlock blocks as an alternative for asphalt layers, but it has some constraints also regarding, for example, speed. It can be used up to 50, 60 kilometer per hour speed, but not no for highways. No, it will not be suitable for that. What do you mind about that?
Okay, so it looks like I have 5 questions with me. Okay, but I'll answer all of them, no problem. I'll answer all of them. One, let's start with the basic thing. If you are using rubber with asphalt cement, creating an asphalt rubber blend, very well researched topic for 70 years now. Mm-hmm. So they've used in Florida, Arizona, California, Sweden, Portugal for 70 years now. Very well product, a well-to-do product in terms of very high volume to low volume. In fact, recently I was also the advisor for Omani government. So I was there in Muscat. So we have paved asphalt rubber section for their highways. Okay, they have had no problem whatsoever with rotting and cracking. Not even one in the last 1 year.
I believe that, but what about overload?
Overload, yeah, absolutely, no problem, absolutely. I mentioned this, it's a friction coarse layer on top of the sound structural layer. You should be able to get even for the overload, absolutely no problem. Especially it works very fine if you put rubber in asphalt for self-crack healing. It is a resilient material. So it has very high elastic recovery to the tune of almost 93 to 95%. So cracking resistance, rot resistance, no problem. High volume, no problem. High temperatures, no problem. Low temperatures, we have paved sections in Sweden, minus 40 degrees Celsius. I was there in Sweden when we paved way back in 2009. They have used rubber across Sweden and many other cold countries, including in Canada for that matter. So no problem with asphalt rubber when you talk about this. Now, if you come to the next question on, is rubber a polymer? Yes, rubber is a polymer, but these rubber particles are from scrap tire. So they are not new materials that act as SBS or SBR. So you should be aware that we are reducing the overall cost by not buying new materials. So it's an old material getting created into a new material. You don't need to even invest on SBS polymer. Polymer works very fine at high temperatures because it gets higher. It has very high viscosity at higher temperatures, but it can get cracked because it is very brittle at low temperatures. But rubber does a good job, especially at all temperatures, because of its low viscosity temperature susceptibility at all temperatures. And this is the physics that we have studied over the years. So
but
rubber
mixed design is very important, Krishna. Mixed design
absolutely, absolutely,
because of the expansion of the rubber.
And that's why I told you we came up with a new technology called the modified asphalt rubber, where we activate these rubber particles and replace the aggregates with respect to the new particles that we have come up with. That also reduces your aggregate consumption. Cost gets reduced by 50%. We have proven it to the government, and we are paving next year. We got a large project from the government, $500,000. We are going to pave across the country with asphalt rubber for all kinds of traffics scenarios. Okay. Next question that you had on the blocks. You are talking about the interconnected paver blocks, and that's what I also mentioned here, right? Now you need to come up with good quality control. Otherwise, you will end up getting low compressive strength. The mixed design aspect with respect to the magic numbers of water cement ratio or aggregate cement ratio, these are the two important key parameters when you do the mixed design. If you are able to come up with this magic number, and what we have seen over the years with 200 mixtures that we have created, the magic number is between 0.25 and 0.35. Precisely 0.3, 0.33. Okay, that's the water cement ratio. Now, cement to aggregate ratio ranges between 1:3.2 and 3.75. So if you are in this ballpark range, I think you should be able to work with it. Now, coming to the supplementary cementitious materials. You didn't ask me, but I'm going to help you with this. Please try supplementary cementitious materials. Don't depend on raw cement because they can be very high cost for you. So you start using fly ash. If you have a lot of fly ash in your country, or a lot of silica fume, a lot of ground granulated blast furnace slags, a lot of pond ashes, a lot of rubber, please start using them. They work equally good and replace cement to a large extent. We have, in fact, used 60% of supplementary cementitious materials. That's big, okay? When you say 60%, that means you've reduced 60% of cement in your mixture. And that reduces the kg CO2 by 80%. So you can also tell your government that, I'm reducing the burden on the environment. Okay. So compressive strength increases, flexural strength increases, all benefits there.
Thank you for the nice presentation once again, and we are looking to cooperate with you in future researches. And if you have materials that can help us or our researchers here in Master of Science or doctoral studies, you can share this material with us.
Absolutely. It'll be a pleasure. It'll be a pleasure from my end.
Thank you.
Sure.
Other questions?
Please feel free. Don't worry. Just ask. Yeah, sure.
Dr. Ala is going to ask.
Sure.
Hi, Dr. Krishna. Thank you for the nice presentation.
Hello. Thank you.
I have a question for the same topic, previous concrete. What about the drainage system? I haven't seen in the video the draining, how water will drain.
Good. I think that was a good question. Somehow it skipped my mind. Very good question, Dr. Ala. You don't need to provide a side drain. If your groundwater table is very low, I'll give you all kinds of scenarios that can help you design a pervious concrete. In fact, we recently, just last week, Sharif, we got a project. When I was in the US, I got a project almost, I think, $500,000 for a complete township. They gave us the entire township to be paved with pervious concrete. And they gave me all kinds of scenarios. They have a groundwater table very high. They have a tree root coming in between. they have low volume road, they have a parking lot, they have a expressway. Everything. Now, okay, if you have a clay soil, don't use pervious concrete. It will not help you. Okay, you have to do ground improvement. Only then you will be able. And so Sharif he's the expert. He will tell you better than me, obviously. Okay, now if you have a granular soil, best, because water drains down rapidly down and then does the groundwater recharge for you. In fact, we have always been suggesting the governments to use granular base course and a semi-permeable membrane, such as the sand, so that water drains down very rapidly. On this, you can pay pervious concrete. If there is a groundwater table that's very high, you cannot use it, because that simply start. In fact, you should not be using a road when there is very high groundwater table anyway, right? So you are looking at a highway being elevated. So don't use groundwater table very high. Now, talking about the side drains, you provide side drains only when you want to have a rainwater harvesting pit. Let's say you want to recharge your irrigation, you want to water your plants, you want to use this water as flushing of toilets, provide side drains. So you have your water coming from pervious concrete, going to semi-permeable membrane, goes to the side drains, and then you can replenish it. I hope that answers your question.
Okay, thank you.
Sure.
Krishna, most of the population in Egypt, we live around the Nile Delta area or around the Nile, which is really a clay material. But if you go west or east, it's a desert. It's a desert environment, so it can be used, in these places but we still have people, living out there. But or around the Nile, we cannot use the pervious pavement. But for the new cities that are being built in the desert areas, this is a very nice option.
Absolutely, because not
Especially
only groundwater recharge,
you don't have that much rain. Yeah.
Now, what I was trying to tell you is this also helps in reducing the heat, so you can walk. The urban heat island effect gets reduced because of the interconnected pore structure. We have seen with pervious concrete almost 5 to 10 degrees Celsius reduction in temperature, air temperature. It absorbs. Yeah.
First of all, I have a question, Dr. Sharif. But first of all, I want to thank Professor Krishna for his time and his prompt responses to our emails. So we are happy to have you here today. Thank you, Professor Krishna. So I have
thank you.
Thank you very much. So I have two questions. The first one is related to what Dr. Sharif and Dr. Hassan, Dr. Ala asked about the pervious concrete. Because I know that one of the limitations of using pervious concrete is that the longitudinal profile should be level, just to make sure that water will not be accumulated in the subsurface layers. That's my first question. So I'm asking about the practicality that may raise some questions about the practicality of using that kind of pavement. My second question is about the linear economy and circular economy, because I'm really interested about this subject. So I'm just asking, how can we predict the discount rate, especially in some countries that face maybe some economical crisis? So the time value of money is changing rapidly. So it's very hard to predict. Thank you again, Professor Krishna.
Thank you. Okay, two very important questions. I agree with you that I showed you a longitudinal profile which was flat. But we have also used pervious concrete in ramps. Okay, I didn't show you a picture, but we have used it in ramps. We can also use it for a camber situation. No problem whatsoever. In fact, you just have to create a mold that helps you support in that venture. So don't worry on the ramp or whatever that is. The angular, the gradient, all these things can be taken care when you design it. Now, coming to the linear and semicircular or circular, we have data for 50 countries. And unfortunately, Egypt doesn't actually fall into it, okay, for various reasons that Obviously, the government doesn't share all data. So what we can do in terms of having you get involved in this, we will assume the GDP. So there are various factors here that we calculate for the social discount rate. So one is I didn't mention this in this slide, but I can share with you the paper that got published recently in IRF conference, and then there is a proceeding as well. So what we do there is we calculate the GDP is known to us. Okay, if you don't have any other data, there is also this OECD, Organization of Economic Cooperation and Development. I'm not sure if that's the right thing. OECD, anyway, you can Google it. All data from 1961 with the UN and OECD can be used. Okay, and that gives you an advantage of calculating the depreciation. And that's why, this societal preference, economic preference also come into picture with social discount rate. That is exactly why I mentioned conventional discount rate doesn't take care of this. It does not account for any of your economic crisis, but social discount rate takes into account. In fact, we were able to calculate the exact number even during COVID time with our formulas. So, and these are the numbers that are actual numbers. So we can come up with a good research framework for you, for Egypt. And please feel free to email me and I'll work with you on this. We have for 50 countries, so that's big, okay? No one has done this in the past, but we have for 50 countries, includes emerging and developed economies, both at the same time. And what we could find is the depreciation can be calculated, the discount rate can be calculated based on the data that are missing as well. Hope that answers your question, Ahmed.
Thanks a lot, Dr. Krishna.
Sure.
I get it. Thank you.
Please, yeah.
I have another question, Krishna, because we are trying here to mimic the Indian experiment. I guess you guys did a lot of work using like different wasted plastics to improve
Correct.
the asphalt. And
Correct.
we are trying to do the same here, and we like ministries, we established like a field test section using conventional asphalt layer and other layer modified with different types of waste plastic, mostly like low density polyethylene products.
Sure.
So what
Sure.
is your inception about that? Do you think
Okay.
that this is like a good thing to try? Do you have like data from actual field experiments about the long-term performance of such materials, or what are your suggestions regarding this?
So plastic, the basic premise of plastic use in asphalt is to increase viscosity at higher temperatures to resist rotting. Unfortunately, yes. This is based on our experience in our labs, and we have a large project from the government. In fact, ministry gave me the project to work on this plastic, mainly because they have seen a lot of failures. So what we did, now we have come up with a product that is a blend of plastic and rubber. Now, plastic will start cracking at low temperatures. Forget about low temperatures. It will crack if there is very heavy loads, multiple repetitions of loads. So fatigue cracking, no way. You cannot use plastic by itself. Plastic is good for rot resistance only. So what we should be doing is to soften this plastic. It should become softer. It doesn't matter whether it is LDPE or HDPE or PET. There are different types of plastic. I'm sure you know this. So we have a large project, and I have a PhD student right now working on a plastic rubber modification. And we are the only people in the country today who have a product ready and going to place it next month. Okay, so we are going to place this, and it gives you a 30 times better fatigue life, 25 times better low temperature thermal cracking. Of course, it has always been good with rot resistance. So plastic by itself, no way. I don't think it will help you in resisting cracking. So you'll have to soften it. You will have to do it. Otherwise, it becomes so brittle that it'll start to crack. So the experience in India, good for rot resistance, but they have seen cracks.
Okay, but you know that Egypt climate is really very hot. We don't see like very
Correct.
cold climate, and
Agree.
our main distress or our main problem is two things. We have very hot climates and we have overloaded trucks, you know.
That's exactly what I'm saying.
Over
So
our
that's
roads.
Sharif, that's exactly what I'm saying. So if you want to arrest this overloaded truck traffic and that brings in cracking, you need to be using plastic plus some other softer material. The harder the material, the more prone it is for fatigue cracking. And you worked on fatigue cracking all through your PhD. You know that better than me.
No, Walid did.
Yeah, but you worked on fatigue cracking
cracking
as well. So
yeah, I did work on different types of cracking, but the problem here in Egypt, it's mainly I mean, we don't see a lot of fatigue cracking on our roads, even though we have very heavy loads, because what we use is we use soft asphalt. I mean, the asphalt we are using as a base asphalt from the beginning is softer than it should be. So adding the plastic, it increases the stiffness, but not to this degree that we are, you know, afraid of the cracks. So, but the idea of combining two different materials or two different waste materials in order to be able to, I mean, resist both cracking and rotting, this is a good idea.
Yeah. So again, if you're not facing any problem with plastic, only make sure that the plastic is compatible with your asphalt. So compatibility study has to be done. And there are a number of experiments, state of the art, that can help you get to there.
Okay.
Great.
Any other questions, Dr. Ahmed Awad? I guess we have Dr. Noor with us. Dr. Noor, are you still there?
Oh, yeah. Yes, Dr. Sharif, I'm here. I've been listening to the presentation, and actually it's quite useful. And I myself is looking forward to receive this state-of-art experiments that will tell us about the compatibility of our asphalt with different types of plastic. That was very interesting to me. And I would like to thank Dr. Krishna again for his informative and useful presentation.
Oh, thank you so much. Thank you.
I mean, one key point here that Krishna mentioned in his presentation, we have to be careful when using, you know, design methodologies that was developed for specific conditions in America or India, and bring the same methodology without any modification to our country, because we have different, you know, conditions. For example, the overloading that we have, the hot climates that we have, even the inferior materials that we use in our pavement construction and the quality control. We have issues also with the quality control during construction. So we have to be really very careful when adapting any new material or any pavement design system into the Egyptian conditions. And I guess what we open today is a venue for, you know, talking more about, you know, similarities and differences between India and Egypt, like condition-wise. And also, I know that in India, you have very well-developed like design methodologies and codes for a lot of areas related to the infrastructure in general. I guess we have to talk more about, you know, these things, and or also collaborate in research. We have good quality students here in Egypt. You have good quality students in India. Our labs are now up to date. I can say that. And Krishna, you have a very well established lab as well. So what about collaborating between the three of us? Even Walid can, we can share.
Absolutely. Absolutely. No doubt about that. In fact, India and Egypt have been friends for 5,000 years.
Oh yeah.
So we should continue this. I see no problem in it. As you rightly pointed out, you cannot bring in any standard from any other country and then say this can be used in India or Egypt. You have to develop your own thought process that also brings in excellent research capabilities within your own resources. And as you rightly mentioned, you have good PhD students, good researchers. you just have to make use of it. I think you have a great team. Let's work. We are always there to help. No problem.
Sure.
Always.
We'll talk more about that. Thank you so much. It's been almost we're close to 2 hours. I think this is enough for today.
No
and
sure.
I really appreciate your time, Krishna. And we shall do this more often. I mean, maybe once yearly, we should have like a guest lecture like this one, at least.
Okay. Yeah, sure. And what about the in-person? I can go to Egypt as well if you do something there.
You are welcome.
Yeah. You are welcome anytime.
Anytime to visit, and we'll arrange like a very good tour for you here in Egypt.
Sure, absolutely.
So
I haven't
on your
seen
agenda,
Egypt,
and we will send you like an official invitation letter at the time of your convenience.
Absolutely.
Don't come during the summer because it's hot.
No, we are in the same condition. No problem.
Okay. From September to May, this is the best time.
Correct. Okay.
All right.
Sure.
Thank you so much.
Great.
And
thank you so much. And
thank you once again. Thank you.
And please feel free to email me if you want to solve some problem or have any questions that you couldn't ask today. Please feel free to email me.
Sure.
Thank you.
Okay.
All right.
Thank you.
Have a nice time. Bye-bye.
Thank you.
Thank you. Bye-bye.
Bye. Thank you.